Look up on a clear night and you'll see maybe 3,000 stars with the naked eye. On a good night, far from city lights, maybe 4,000. And here's the thing. Every single one of them is a lie. Not intentionally, not maliciously, but a lie nonetheless. Because what you're seeing isn't the sky as it is right now. It's a photograph, a collection of moments from the past, some of them so far back they predate the Earth itself. The light reaching your eye from the Andromeda Galaxy left its source 2.5 million years ago, before humans, before our species had a word for anything. You're not observing the universe. You're reading its mail, and most of it is ancient. But okay, that's the part people sort of know. The light takes time to travel thing. You've probably heard that. And it's genuinely disorienting when you sit with it, right? But it's almost manageable. What is not manageable, what I'm still sitting with honestly, is what that light is moving through. Because between those stars, in all that darkness you've spent your whole life assuming is empty, it isn't. And what's there is so enormous, so structurally fundamental to everything that we've named it, and still have absolutely no idea what it actually is. The universe you can see, every star, every galaxy, every cloud of dust and gas that every telescope we've ever built has ever detected, makes up about 5% of what exists. 5. The other 95% is invisible, not distant, not hidden behind something, not waiting to be discovered in a far corner of space. It is here, everywhere, threading through you and the chair you're sitting in and the planet beneath you right now. And we cannot see it, touch it, or explain it. We know it's there because of what it does to the things we can see. And somehow that's not even close to the strangest part. Here's how the math breaks down. Of everything in the universe, all of reality, roughly 27% is what physicists call dark matter. It doesn't emit light. It doesn't absorb light. It doesn't interact with light at all, which is why it took us so long to notice it. What gave it away was motion. Stars at the edges of galaxies were moving too fast, way too fast. According to the visible mass of those galaxies, the outer stars should have been flung off into space billions of years ago, but they're still there. Something is holding them in, something with gravitational pull that we can measure precisely and observe nowhere. Astronomers modeling this called it dark matter because they needed a name for something they couldn't see. And dark was honestly the most honest word available. The detection method that finally made this undeniable was gravitational lensing. Einstein told us that mass bends space-time, which means mass bends light. So astronomers looking at distant galaxies behind large clusters started noticing that the light was bending more than the visible mass could account for. There was more gravity than there was visible stuff creating it. Think of it like holding a sheet of clear glass over a grid. You'd know something was there by the way the lines bent, even if the glass itself was perfectly transparent. That's how we see dark matter. Not directly, through its fingerprints on light that pass through it. And then there's the other 68%. This one genuinely keeps me up at night. Because dark matter, strange as it is, at least behaves like we'd expect matter to behave. It has gravity. It pulls things together. We don't know what it's made of. WIMPs, axions, primordial black holes. Physicists are still arguing. But it acts like stuff. The 68% doesn't act like stuff. It acts like the opposite of gravity. Astronomers measuring distant supernovae in the late 1990s found something that should have been impossible. The universe's expansion wasn't slowing down. It was speeding up. The galaxies weren't gradually drifting apart the way you'd expect after a big bang. They were accelerating away from each other, faster and faster, as if something was pushing from inside the fabric of space itself. They called it dark energy. And I want to be clear about this. We don't know what dark energy is. We don't have a leading candidate. We have the name, we have the measurement. The universe is expanding at an accelerating rate, and we have essentially no explanation for why. If this is the kind of question that lives rent-free in your head at 2 a.m. in the best possible way, subscribe, because this is exactly what we do here every week. New video, new rabbit hole, and I cannot promise you'll come back from any of them unchanged. Now, the dark energy piece has consequences. enormous, architecturally fundamental consequences. Because if the expansion of the universe is accelerating, then the voids between galaxy clusters, the genuine nothing between the filaments of large-scale structure, aren't just staying large, they're growing. Right now, the observable universe contains massive regions of near-total emptiness called cosmic voids, some of them tens to hundreds of millions of light-years across, containing maybe a few atoms per cubic meter. To compare, the air you're breathing has about 10 to the 19th atoms per cubic centimeter. These voids contain almost nothing across distances that would take light millions of years to cross. And here's the thing about cosmic voids I find weirdly beautiful. They're not an accident. They're the reason everything else exists. In the early universe, tiny quantum fluctuations in density created regions that were very slightly more packed with matter than others. Gravity did the rest, pulling matter toward those denser regions over billions of years, leaving behind the voids. The structure of the universe, every galaxy, every cluster, every supercluster arranged into vast cosmic webs, is essentially the scar tissue left behind by the voids. The emptiness created the architecture, which is not nothing as a metaphor. There are galaxies inside these voids. Isolated things called void galaxies or field galaxies, billions of light years from their nearest neighbor, still slowly forming stars in the middle of essentially nothing. I find this almost unbearably poignant. Stars turning on in the dark with no one nearby to notice. The dark energy is accelerating all of this. The voids are growing, and the web of filaments connecting galaxy clusters is slowly thinning. The Milky Way and Andromeda will merge in about 4 billion years. That one's local enough that gravity holds us together, but the galaxy clusters beyond our local group, they're already moving away faster than light can bridge the gap. Not because anything is moving through space faster than light, but because space itself is expanding. And at large enough distances, that expansion is faster than light can compensate for. Which brings us to the edge of what any instrument we build will ever see. The cosmic horizon, the edge of the observable universe, sits about 46 billion light-years away in every direction. Not 14 billion, which would be the naive calculation from the age of the universe. The universe has been expanding the whole time light was traveling, which is why the observable universe is larger than the travel time suggests. 46 billion light-years in every direction, and that's just the part where light has had time to reach us. Beyond that boundary, there is more universe. Almost certainly, vastly more. But we cannot see it, and we never will. The oldest light we can detect, the cosmic microwave background, the CMB, comes from about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light to travel freely for the first time. Before that moment, the universe was a hot plasma that light couldn't penetrate. That wall is the ultimate edge of what's visible. The Planck satellite mapped it in extraordinary detail. Tiny temperature fluctuations of just millionths of a degree. The seeds of every galaxy that would ever form. Light that has been traveling for 13.8 billion years still arriving, still reaching us now. That, by the way, is the oldest thing you can experience with a radio telescope. Everything before it is behind a curtain we cannot part. Here's the thing I want to leave you with. Because of dark energy's acceleration, future civilizations, if any exist in the universe millions of years from now, will look up at the night sky and see almost nothing. The galaxies currently visible will have receded beyond the cosmic horizon. The local group will remain, but everything else, the hundreds of billions of galaxies the James Webb Space Telescope is mapping right now, will simply be gone. Not destroyed, just too far. Receded past the edge of what light can bridge. Those future observers will think the universe is their local cluster and nothing else. They will have no evidence of anything beyond it. They will be wrong in a way they cannot detect. We are living at the one moment in cosmic history when the universe is still visible, when the expansion hasn't yet stolen the evidence of what's out there. Every galaxy in the Hubble Deep Field images, every ancient light the Webb is capturing right now, in the very long run, that view is temporary. We happen to exist at the moment when you can still look up and see 13.8 billion years of history written across the sky in light. That's not a small thing. That's actually somehow extraordinary. Before you go, drop a comment and tell me, does the dark matter mystery or the dark energy mystery unsettle you more? One is something we can't identify. The other is something driving all of reality apart, and we have genuinely no idea what it is. I want to know which one breaks your brain first.